Hi folks, today we're going to talk about cube calculations. You're going to see lots of examples of them. It's a really important topic because cube calculations should be your primary source of real-time model logic. And I say that because there's a lot of ways you can create model logic, right? I could create dimension expressions, I could create links, I can use weights and aggregation in my model. If I wanted point-in-time logic, I could be creating processes. I could use subsets, MDX, all sorts of ways that I can create logic in my model. But this one should be your first approach when you're doing something real-time. And I say that for a couple of reasons. So they're very powerful. I can create context in my expressions that apply to ranges of cells, whole cubes, or even just a single cell. I can use syntax that makes a lot of sense. It looks an awful lot like any of the spreadsheet syntax that you've used to date. So I don't have to quite learn manual rules yet, although we'll certainly cover those later. I can very easily specify that those get fed for me, so I don't have to learn feeders just yet. And of course we'll learn that as well. But it's a very simple way to start. It's not very abstract. It can work right off the face of the grid. And the implementation of cube calculations is always as an actual rule. So it'll help teach me rules as I go. I can create a cube calculation, look at the output, and see what that looks like as a system rule, which is great and helps me learn that in case I have to do it myself later on. So we're going to use our hotels example again. We're going to create a number of expressions within a cube calculation. We're not going to touch links inside of cube calculations yet, just so that we can get this to fit in a reasonable amount of time. We'll cover that another day. But even with that, we probably have quite a bit to cover, so let's get started.
You'll recall our hotel performance cube that we built as we looked at creating dimensions. I've just made a few minor tweaks to it so it's a little simpler and a little easier to look at as we start building expressions. So for example, I've switched to use a month's time dimension, so just months rolling up to a year. And I've made a few changes to our measures so that we can start building up some real-world valuable expressions incrementally until we fill this model out. You'll notice as well that in this view I'm looking at a single leaf level hotel, and that allows me to test my expressions as I build them. Which brings me to my last point about getting started. When you're just learning, don't worry too much about getting some actual data in there to test. You can quickly use some shortcut keys to put some dummy data in long before you've decided on your final import approach and how you're going to load actual data. So we'll add some rooms related operational expenses now so that we can very quickly create our rooms profit margin calculation. Creating a cube calculation for our room's profit margin is as easy as right-clicking the grid and choosing to create cube calculation. But what you might not realize when you do that is that your selection is used to create the default scope of the expression. So a better habit to get into when you create cube calculations is to think about the scope as you're creating the expression. So I don't want this expression to apply only to January. I want it to apply to all months. If I was worried about whether or not I wanted forecast to be calculated different than actuals, I might just put forecast here in the grid so that I could focus on that. Now you can always change your mind later and adjust the scope, but having a good default will save you time. You can review or change your scope using the overview area. So for example, if I wanted my expression to only apply to a particular version, I could easily do that here and say this only applies to forecast. I can also remove items from the scope of the expression just as easily. To create the expression itself, if I know exactly how my measures are spelled and how I want to use them, I can simply type in the expression window. But I do have to qualify those member names for the dimension that they come from, just in case that member name is used in another dimension. And more likely what you'll want to do to avoid errors in member names and things like that is to just grab them from the editor right here. So I can simply locate the member that I want. So for example, my room's revenue minus my room's expenses. Now you may have noticed while I was typing that I was getting errors over here in my Power Editing support window. Now the reason for that is that we're checking in real time for any syntax errors that might exist in your expression. But I can very easily correct those and ensure that my expression is valid before I apply it. So that looks good by my math. Let's give it another try and create an expression for our room's profit margin. So just like we did before, I'm going to select room's profit margin so that my selection is the whole member, and then I'm going to create a cube calculation. I'm going to call it room's profit margin percent. I'll click OK. I'm going to close my other cube calculation. These will build up on you, so it's a good practice to get into to close anything you don't need. And just as we did before, I'm going to locate the members that I want. Of course, our profit margin percentage is our profit margin divided by our revenue. I'll apply that and see the result. And if I want to test with some simpler numbers, I could just say that I made 100,000 and see that that's 60%. So that looks great, but if I look at my total for the year, I can see that I've got a problem. And the problem is related to how I've created this expression. This is a leaf level expression only, which means that at the month level for my leaf level hotels, I'm performing a calculation for my room's profit margin percentage. But for consolidated levels, the default is to just aggregate those, so just sum those. And while that works just fine for my room's profit margin and works fine for my revenue and expenses, that doesn't work when it comes to my room's profit margin percentage. Now occasionally we'll create very explicit consolidated level expressions, things like averages, time averages, all that sort of thing. But in this case, all we need to do is make the expression the same for both the leaf or month level expressions here as well as the full year. So if I apply that, we'll see that I've now got the correct profit margin percentage at the full year level. Now you might wonder, should that be the default then? Should I always combine my leaf and consolidated expressions? And the answer is no. Wherever possible, you should let the aggregation engine do the bulk of the work by calculating at the leaf level. Obviously, if we need to, we create consolidated level expressions or use the same leaf and consolidated expression. But if you don't need to, you shouldn't, and this is a logical default. In this particular cube, we may use quite a number of expressions where we want to combine leaf and consolidated items. Typically things like percents, a number of our KPIs here like per occupied room, per available room, are cases where it wouldn't really make sense to sum the numbers. We get nonsensical values. But in the majority of cases, you will just want to let those aggregate. So with our room's profit margin complete, let's look at our available rooms and create an expression for that as well. Similar to our last approach, I've highlighted my available rooms. I'm going to create a cube calculation for available rooms. And then I'm going to do something that I don't ever want to see anyone else do. I'm going to hard code a value in an expression. Now, in another video, I'm going to show you how to use links, where we're going to retrieve this value on a per hotel basis from a cube that's going to contain the number of rooms that I have in a hotel. But for now, we've just hard-coded it. Please don't try this at home. Now, our available rooms measure is in fact the product of the number of rooms that are in the hotel, physically in the hotel, times the number of days in the period for which I could have rented one of those rooms. You'll recall when we talked about dimensions that I told you that when you specify something as a time dimension, that we add a number of useful attributes to that dimension. I wasn't lying. If we take a look at the attributes of our months dimension, we see that we have a start date and an end date attribute. Now, just like in a spreadsheet, although dates appear as a date, they're actually stored as a number so that you can do math on those. So for example, if I take my end date and subtract my start date, I'll get the number of days that were actually in that period. because cube calculations allow us to access these attributes of any dimension very easily. I don't even need to use a special function. I can just apply this expression and see the result. So we do have more available rooms in January than February. In fact, 3 days worth, if I've got 50 rooms times 3 days, that's the 150 we see in the difference. And if I look at my full year number, it is, as it should be, the sum of all of those months. You'll recall when I introduced this topic that I told you that cube calculations were a really great way to start and a great way to learn manual rules in case you need to or want to use those later. This is probably a good time for us to take a look at manual rules. Rules are how TM1 actually interprets the logic that you're creating when you create a cube calculation. So Performance Modeler generates typically these rules for you. So if you look here, this is the rules for my hotel performance cube. And you'll see that there's a region here for every expression that we've created so far. When you first look at a rule, you may find the syntax a little more daunting than that which we use when you're creating a cube calculation. So if I look at the expression that we just created that calculates the days in a month and multiplies that by our hard-coded value for number of rooms in the hotel, you can see that this might take a little while longer to learn. The great thing is that for almost all of the capability that you'll create in the model, you don't need to learn this. You can use cube calculations and allow Performance Modeler to generate the system rules. You can often create a number of cube calculations to get to a final result, and that will afford you the full flexibility that you would get from writing a manual rule. But there are occasions you may find where it's more efficient and practical to actually just write the rule yourself, or use portions of a cube calculation that's been created for you to then start your own expression. And there is nothing wrong with doing that at all. So Performance Modeler was built to allow you the full range of flexibility that you would normally get when modeling with TM1. I can disable any of the generated expressions and write my own expression. In this case, copying and pasting to get a head start. I'm going to make a minor adjustment to the expression that we were just working with because it only included the end date of the month I'm in rather than adding a day because we want to look at actually the first day of the next month. So I can just add that here, and that rule will be treated no differently than the others, and we're not going to try to generate that cube calculation again. Now you would have probably wanted to make that change within the cube calculation. No problem, you could do that there and it would be generated to account for that change. But once it's been disabled, that won't happen. And the only caution that I would give you on this topic is that once you start creating manual rules, when it comes to maintaining the model and looking at the expression logic, for your own sanity, you'll really want to do that here rather than in the cube view itself. And I say that because any of your manual rules don't show up obviously as cube calculations when you try to review the calculations in the model. So know that cube rules are there, that they provide you a great deal of flexibility, but that they can be trickier to learn and take a little longer, but are fully supported and intended to be a part of your experience in Performance Modeler. How and when you choose to use them is entirely up to you. Now let's get back to building some more expressions. So first, I'm going to populate my rooms sold, so I'll just come up with one value here to use for all months. We'll say we sold that many rooms in a month. And now we'll create our occupancy calculation. Now occupancy is a rate that's very often used in the hotel industry to tell us the difference between how many rooms were available and those that were sold as a percentage. So very much like our rooms profit margin percentage, what we want to do here is take our rooms sold and divide that by the number of rooms that we had available. And like our rooms profit margin percent, because this is a rate or a percentage, we want to make sure that we're not aggregating when we intersect with consolidated level expressions. So I'm going to combine those to see that we have an annual occupancy rate of 85.71% for 2017. Our average daily rate calculation is actually based on not our revenue, but our revenue per occupied room. So let's create another cube calculation, And we know that this is sort of per day per occupied room, so we'll combine our leaf and consolidated values, and then we'll divide our room's revenue by the number of rooms that we've actually sold to get our actual selling price for those rooms. In this case, looking like we deeply discounted February. Of course, that's because I deliberately decreased our revenue for February as well. And if we look at our full year value, we see, of course, the same daily rate. And now we can move on to our room's RevPAR, which, as you can probably see here, has a typo. There are two ways of dealing with that problem. The first one is the one I would use here if I had a really well-developed model with lots of rules, lots of processes and things already in place before I noticed it or needed to make a change. And I would make that change by adjusting the caption in those cases. So now I have a caption that I can use in my cube views that will reflect the name that I wanted this to have. So we'll save my hotel measures here. I'll change my subsets to use an alias. So if I click in the columns here, I can look at the display options and say just use the caption that the users are going to see. And now it looks correct. But what I just described to you is what I would do if I had a really well-developed model. I don't. We're just starting. If you have the opportunity when you're just starting, delete this, because the underlying name, what we'll often call the invariant name of an object, will always stay the same. That's why we use the word invariant. It can't change. So what I would do is delete this and create another. Move that back to where I wanted it, copy my format so it's consistent, and get back to building our expressions. We'll close these expressions and create another one exactly as we did before. Still working with these rates and percentages, so combining my leaf and consolidated expressions. This one is going to be my revenue divided by my number of available rooms as opposed to my occupied rooms. And this metric, of course, would improve as I increased my occupancy rate. And now just finishing this view off with my cost per occupied room. It's a new cube calculation. And that's simply going to be my costs divided by the number of rooms I actually sold. That one, of course, also the same for our leaf and consolidated elements. So before we finish this video and move on to other topics, I want you to think for a moment about what we've created here. So with a very small number of expressions, in fact, just the 7 you see here, from 2 input values, I've created a lot of information about this hotel. And in fact, all of these expressions are going to be in place for all of my hotels. If this were a spreadsheet, I would have had to create 3,000 expressions to do this. Now, of course, I'd have dragged existing expressions to populate them, and it might not have taken me much longer than it did here, but maintaining those consistently would have been quite a challenge. So in the last 20 minutes, we've learned that cube calcs are the primary approach for creating real-time model logic, but that we can use generated rules to learn how to write manual rules. We learned how to scope an expression to only apply to the cells we want it to, and how to apply our expressions at both the leaf and consolidated level of a cube when we're working with rates and things like that. We created simple expressions to calculate common rates and KPIs that are used in the hotel industry, and we learned how to use attributes in our expressions. We saw that we could modify generated rules by disabling them and copying and pasting, or that we could write our own if we wanted to. We created many calculated values from very few actual calculations and with very little effort. Now we're ready to learn about links, functions, and more. So stay tuned. And as always, thanks very much for your time and happy modeling.